You're listening to the Business Innovation and Technology Podcast, conversations with industry leaders on new trends and products that can grow your business. Today, host Jordan Rogers-Smith is joined by Miku Jha, the Director of Applied Research and Development and Business Messaging here at Meta and founder of AgShift. They are also joined by Peter Wang, founder of Anaconda. Together, they discuss machine learning and artificial intelligence, how rapid changes in these technologies impact the way we live, and also what their effect will be on the world of marketing.
You are listening to the Business, Innovation and Technology Podcast. I am your host, Jordan Rogers-Smith, and today we're going to be digging into the topic of machine learning and artificial intelligence, really looking at how the rapid changes in these two areas are really impacting the way we live and how the world functions, but also how these technology changes are going to affect marketers and the way they approach their work and what we should expect in the future as well. To join me in this discussion, we've been joined by Miku Jha, Director of Applied Research and Development and Business Messaging here at Meta, and also simultaneously founder of AgShift, and Peter Wang, founder of Anaconda. So it's great to have you both here, and I'd love for you just to start by telling us a little bit about yourself. And Miku, I'd love for you to start.
Sure. Thanks, Jordan. I'm really glad to be here. I'm Miku Jha. I joined Meta last year, July, so very much coming on my first year anniversary at
Congratulations.
Meta. Thank you so much. Can't believe it's going to be a year. Things go really fast at Meta. And here I'm leading applied research and development and business messaging. But, essentially the goal, the aspiration, the intention is also to figure out how we can leverage AI as a multiplier to get our businesses, most importantly, our customers, our partners, to 10x, 20x, 100x from where we are at today. And AI ends up being one of that fabric, a multiplier, which can get us there. Prior to Meta, I was the founder and CEO of an AI ML company in food tech, which was AgShift. And there, essentially, the idea was, again, to apply AI in a meaningful way to be better about how we can grade food and overall reduce food waste. So I ran the startup for almost 7 years. I think I grew up to be a very different person before and after AgShift. And prior to that, in total, I have founded 12 different startups. So I'm pretty much a startup junkie in many shapes and form. But happy to be here on this podcast and sharing some of my learnings with the broader team and the audience.
It was great to have you and welcome. And Peter, tell us a bit about yourself.
Yeah, so I'm the CEO and co-founder of Anaconda, and I started the company about 10 years ago after doing a period of time I was doing consulting using Python in numerical computing and engineering simulation and things like that. And I saw an opportunity to really take Python into a broader business set of applications. And that led to the creation of many of the different kinds of technologies that people use today, and certainly the coalescence and the convergence of a community called PyData that I put together to push the use of Python in data analysis. But my formal background is actually in physics, and I joined the software industry, I guess, joining startups right out of college in the first .com boom. So I've also been a startup junkie, and I've never really worked at a big company before, although I've done a lot of consulting at them. I've walked through the doors. But right now, every single person Anaconda hires, that makes Anaconda the biggest company I've ever worked at, right? So it's still, we're now, 250 something people, and it's the biggest company I've ever worked at, and I happen to be the CEO. So there's some learning there, but it's been quite a process. And I absolutely, appreciate what Miku says about the journey, right? The founder journey, the entrepreneurial journey over whether it's 3 years, whether it's 7, 10, 20, it's just a process that, everyone who's been through it, they realize how much they transform through it. So it's great to be here with you guys. And I really appreciate the opportunity to come on this podcast.
No, it's fantastic to have you. As I said, fantastic to have you both here joining us talking about this topic. And the very first thing that I actually want to try and demystify or understand a little bit better is that AI and machine learning are generally used interchangeably or together within, the media and the press. Like, are they the same thing? Are they different? Like, do you mind just the very top, just describing how to talk about this topic, whether it's two separate things, one thing, and then they're synonyms. Like, what does it actually mean?
Miku, you want to go ahead?
No, I will let the physicist go at it first.
Well, I've got the what I think is the concrete kind of technical take, and then I've got sort of like the snarky take. We'll maybe do both and see what you like. So the actual thing, from my perspective, there's the broader space of predictive analytics when we try to predict things, right? And in some problems in the world, we have well-established engineering and physics equations we can use to predict what happens. Now, outside of those analytical regimes, we have just phenomena we observe. And then we have to try to categorize and try to figure out what is a model that explains how the inputs cause the outputs to happen in this particular set of phenomena. But we don't have a theory of it. We, like some math equation we can write out. So we apply computer techniques to try to classify, to partition, to create some flow of causality and whatnot. And that broad set of approaches there is machine learning, or you call it modeling in general, but machine learning is one subset of modeling. And then as a subset there, when you use a particular set of techniques where you just have a tremendous amount of data and you have no idea how to model it at all. I mean, even machine learning, there are well-known techniques, and there's some charts that show you which things to use if you're doing supervised or unsupervised learning. But there's a set of things where we just have no idea, and we're going to take these things called neural networks, and we throw these giant amounts of data at giant amounts of hardware, GPU hardware, and out comes something that seems to predict stuff, but we don't know how it works. And people generally call that part AI. So I really see it as sort of the barrier of explainability. Once you can explain exactly what the model was, then it's like, oh, well, you use this thing, and this thing, models this and maps into that. And then it becomes like, well, all you're doing is machine learning. But if you really just threw a bunch of data at a bunch of hardware and you get something that kind of works, and you're like, I don't know though, like, I don't know how it worked. I think that people call that AI. Also, if you're fundraising, you call it AI always. That's a snarky take.
Well, Peter, I wish I knew this tip before. I kept calling it ML when I was fundraising. but to simplify it, Jordan, one way to look at it is that AI is the superset, and ML is one forms of expression to get to that AI. It's not the only form, right? So, like, essentially, if you go back to 1950s, whenever, what was AI? It was essentially, is there any path to which you can train a system and augment that so that it becomes more repeatable? That's because now you're using a system in the equation that's artificial. And since it's smart, if it can learn on its own and become smarter, that's the intelligence part. So that was AI. And whether I achieve it through an Excel sheet, whether I achieve it through a flow chart, whether I achieve it through a machine learning as a way to get there, ML is just a very simple, like, one path to get there. There are a lot of other ways to get there. Like, even like what Peter said, depending on what model you're using, are you using the neural networks, or are you using a simple linear regression? How do you explain it? All of that becomes part of ML. I hope I touched it at a slightly higher level from Peter, just to make it easier.
Yeah, and actually, Miku,
no, definitely.
Sorry. I really want to build on that, because you're absolutely right that it's not merely AI, but it's cybernetics, right? Because back in the 50s and 60s, they're talking about building control systems, and how do you make a system that is able to respond to its environment in the optimal way, right? In the same way that a very intelligent human agent would. Right. And that is really the essence of the term artificial intelligence. And then it came to resurgence in the last, 5-6 years, because of a certain subset of techniques in machine learning, coupled with this ginormous amount of data from sensors and from whatever, we're able to show some absolutely astonishing results using these techniques. But it's still a subcategory. All the machine learning stuff, it is a subcategory of this general cybernetic problem that we've always, to some extent, I would say the computing world is somewhat forgotten, right? While it was building database systems, while it was trying to just process everyone's credit cards to buy stuff online, do e-commerce, we sort of forgot that all the computing stuff started with people trying to build anti-aircraft guns and trying to build these control systems that would track what was happening in a changing environment. And now we're sort of back to the future. back to cybernetic systems, although that term is still not in vogue yet, but I'm going to try to bring it back. It's the right term. So thank you, Miku, for bringing that taking that up to the higher level.
Absolutely.
And so for people not, familiar with this space, like myself, I will hold my hands up at the very beginning and say, I am not an AI or ML expert in any way. I wouldn't even classify myself as having a very solid baseline knowledge. And so it can be quite daunting to look from the outside and try and understand what's going on. And for marketers out there, or, for people who understand that this is going to be impacting their space in the future, or even impacting their space like now and may not be aware of it, like what would be a way or some ways to try and, bring them up to speed on these technologies? And what are some of the examples that you can think of and share where marketing leaders are being affected by AI and ML today?
I can go. Essentially, Jordan, first thing is that nobody is an AI ML expert. I just want you to have that takeaway.
Oh, good. Thank you. Makes me feel a lot better.
If you're calling yourself an expert, you just haven't gone through the pain. That's, but, in terms of, you're absolutely right that it seems like a very daunting space even to start with, right? It seems overwhelming. And the way, I think, but for marketers or for even any industry vertical or decision makers, I think the approach doesn't have to change from how you look at a traditional business problem and a potential solution for that, right? Like even here, the approach could be similar. That is, you work backwards from a business problem because, it's not that every problem lends itself to be solvable only by AI. That's a big misnomer that, AI is not for everything, right? Like, if you can solve it using simpler ways, using simpler workflows, using Excel sheet, using whatever XYZ, which is easier than AI ML, then I think you should go for that. That's the first thing, that it's not for every solution. And then once you focus on the problem, I think you have to also analyze, this is something which was based from my own learnings, that you have to analyze that are you intending for AI to solve it fully, like 100% automated? That might be a paradigm, but if you can break it down to where it can start from the augmentation, that's where, at least in the non-software industrial verticals, like Peter touched upon the control systems and all of that, IoT, when you go there, you start seeing that when you start augmenting it with the human experts, that's where you start getting at least a good ROI from the AI ML systems. So to drive it with an example, right? Like what we were doing is we were trying to improve food grading. Today, it's done by people like experts who know how to look at a sample of strawberry or cashews and call out this is A versus B based on visual patterns. Now, the question is, the entrepreneur's mistake, right? Day zero, the vision was fully automated. Let the system do everything. Burned 2 years down the road, didn't work because we had data problem, we had infrastructure problem, but we also had the subjective interpretation problem. That is, how do you even get to the benchmark that this is grade A versus grade B? Then we changed our equation to say, okay, fine, we are not the final decision maker. Let the expert be the final decision maker. Let the AI system, rather than inspecting 1 pound of strawberries, inspect 100 pounds of strawberries, because the system doesn't get tired and you're giving more sample and data points to the expert to make that decision. So I think augmentation, I'm a strong believer of it because I have the hard story to tell where I had to pivot. But I think it's a good starting point for any business leader to start from a very basic paradigm. What is the problem? Work backwards from there. Get the expert assessment that is this lending itself well to be solved by AI ML, or is there a simpler path? If that's the only answer, establish the guardrails, go with the augmentation, and then put it into works as a basic MVP or a first version of the product.
Yeah, that is spot on, and I don't have much to add to that other than to say that to touch on something that Miku sort of talked about, which is a lot of times when people approach these things, especially if they don't know much about AI/ML, they want to treat it like it's some magic pixie dust. I have a hard business decisioning
Yeah.
problem. If I sprinkle enough AI on it, my magic business decisioning problem goes away, and I just get money out the other side. I put in, GPU cloud hours, and I get money on the other side. And it never works that way. Because what ends up happening is you start realizing as you start, let's say that the AI, in the best case, the machine learning system or the AI system you build, it'll help you do certain things faster or do the same thing at broader scale or to a higher level of quality.
Mm-hmm.
One of these axes, you'll get better in some ways. That's what makes it a successful implementation, let's say. But it's never just a silver bullet for all of your business problems. In fact, sometimes successes lead to bigger business problems because you're like, oh, I can really predict now when my customers will buy things. So I can really predict exactly what I need to stock. But if I just completely shrink my inventory to just those things, if things change, then I actually have a bigger variance in my outcome to report to upper management or to investors. So you really have to, it forces in all cases, successful engagement with AI ML as a discipline forces the business decision makers to think more deeply about what they're actually doing as a business. And later, if we talk at all about ethical AI ML kind of things, we'll get to that as well, right? Like this is not a technology problem; it's technology pushing people into facing the actual underlying business problems that maybe when they had a lower fidelity process through, let's say, some Excel spreadsheets being mailed back and forth between VPs of whatever, like that process, there's a lot of slack in it and a lot of slop. Once you actually turn these systems into automated reasoning and automated computing and inference systems, then you're face to face with like, oh crap, we really can know this. We can decide that. We have to make a decision what we want to do, right? And so I think augmentation, to Mika's point, exactly is, I think, where most of the impact for AI ML in this world will be felt. But what it will always do is it'll always put a problem right back upstairs to management and to business decision makers about the what. What are we trying to do? It's not merely a how question, right? It's a what question, somewhat a why question.
Yeah, and Peter, you touched on something very important that, when you try to go from the status quo, whatever it is, to an AI ML system, many times we undermine the cost of it. And cost, I don't mean just the monetary cost of, getting to new infrastructure, having ways to support that system, hiring the new tech to understand how the models will work and all of that. Cost is also in terms of changing the behavior of people and the cost of bringing new systems into place. Like you have relied on a completely different way of decision making, and now you're going to rely on something which your best case scenario also is not going to be 100%. Let's face the reality, right? Like those performance numbers and precisions and recalls, they do have variations and spikes. How do you factor for that in real time decision making, right? So a lot of these change management which has to happen for an organization is equally important to comprehend. To what extent you're going to push, roll out, deploy, and start using AI to make those decisions for you, because it directly impacts the bottom line, right? Like if, for example, if a food industry uses an AI system to make a decision on accepting a certain sample or a shipment, which might be worth, say, $100 million, it's a big decision, because if you're relying on AI system to accept or reject it and it goes down the food chain, that's going to come back to you if the other end of the ecosystem say, I do not agree with what you have rejected or what you have accepted. You have to factor in for a change management within the organization. More you deploy and roll out, bigger is the scale of change management also, which is something which is never thought of till you get to the deployment point. And then it's kind of a oops moment that, okay, how do we actually use the information in which we have invested last 6 years to build the models and the accuracy?
Yeah, people always
right?
Sorry. So you've both...
Oh, sorry, I was going to say, people absolutely underestimate the degree to which success is a challenge. They worry about failure. Oh, we spent all this money. We hired a data science team. They built some AI stuff. It didn't work. Womp, womp. We have to write down all the costs. But if it works, bad news, right? You actually you're faced with organizational decision, like the decisioning at an organization level. There's political change that has to happen within organizations to really have those AI technologies, mate with the traditional decision-making processes and not have it be just a finger-pointing exercise when something goes wrong. Like it's actually, I think that's starting to become more appreciated as people adopt these things more, but it's still something that I think was quite unexpected for a lot of businesses.
Absolutely
And so
right
to think
on,
about,
Peter.
I was going to say, to think about your own respective experiences, when you were approaching these problems, and just trying to tie it back to, others who may be approaching these challenges, for the first time, or being tasked with the decision of, well, is this an AI or ML problem? Is this not an AI ML problem? I guess how would you guide them through that thought process and actually being able to make a decision about, okay, when do we actually need to apply AI and ML? Because, in the traditional product world, you would do things that wouldn't scale. If you're in a startup, the advice is always like, do it so it doesn't scale, and then figure out how to make it scale once you've found that it works and you have, the product market fit. Like when it comes to AI and ML, do some of those old product design mantras still apply? Do they not? Like, how should you think about approaching such a decision? Whereas you say what happens in the inside can be a very black box, and it's very hard to understand and know what's going on.
Yeah. I would love to hear Peter's take first.
Yeah, so I think that the mantra of find the product market fit and then figure out how to make it scale. For software apps and things like that, of course, that was a very popular piece of advice. There's many industries for which that's not really great advice, right? But when it comes to AI ML pieces, if you want to found a machine learning based startup, and for me, by definition, what that means is that you believe the use of data and automated reasoning can produce some massive amount of value, right? That has to be your thesis, to say, I'm doing this AI ML project, I believe that this will provide this much value. So to some extent, you must already have a suspicion that scale is possible, right? It's not like, in your case, Miku, of like looking at qualifying food coming down a conveyor belt. You didn't say, hey, I wrote a piece of OpenCV code that's able to tell the difference between a cashew and a strawberry. And imagine if I could do this at volume, right? It's more, you look at the literature, you look at what's happening. You're like, hey, I think we can actually apply some automated AI infrastructure to do this thing at scale. So I would say for the people who are serious about doing it, there's almost scale is baked into how you reason about where the value comes from, whether it's scaling out a marketplace, whether it's scaling out, whatever it might be. I feel like for the AI stuff, like a lot of people understand that right now it's the glut of data we have and our ability to observe a lot of things at much greater scale, coupled with the fact that we can rent supercomputers, which you couldn't have done 15 years ago. You put all those together and you have the opportunity to build a business model that transforms how somebody thinks about a problem, how a problem has been done classically. But scale is kind of built into it. So to your question, Jordan, I think that's for a lot of those kinds of businesses, that is, it's different than the traditional advice that's been given.
Yeah, to add to Peter's point, I think, Jordan, to your question is, does this follow, at least to some extent, a traditional product market fit kind of a paradigm? I think two things change in the AI/ML world. One is from the technical execution perspective. Like, do you have enough data even to take the first step? It will be surprising, but the moment you switch from like something like Meta, where we do not have lack of data, we have data at the traditional software scale, but you switch to a non-software industry vertical like food or industrial automation or whatever, you don't have a starting point. So like first question is, okay, how are you going to build that basic training set even to attempt a reasonable AI ML model? That becomes one paradigm. And second, to Peter's point, is explainability, right? It's a black box. If you are not in a position where you can explain the results and the outcomes in a at least moderately predictable way, obviously you'll have spikes and spurious results one-off, but for the most of it, if you can't explain it, no matter how good the results are, averaging it, aggregating it, whatever you do, it's not gonna get past a good MVP deployment to something in scale. Because when you are looking at scale, you are looking at a business audience, right? They have to be able to explain the results, the rationale behind those decision making, to their stakeholders. And if they can't explain it, there's no way the system will get the adoption. Like if you're in food industry, we had to explain it to growers who were growing the strawberries and almonds and cashews, because you were rejecting their shipment, right? So you have all the right to say, why was this rejected? And the minute you say it wasn't done by a person, it was done by a machine, just imagine that conversation from that perspective, right? So it's very tough. Even if you look at, let's say, at meta scale for certain ad campaigns, if you go to thousands of customers and say, hey, this is the recommendation how you should be running the ad campaign, you have to do a fairly good job of explainability and ROI, and why are we recommending what we are recommending, right? Because you don't have the luxury of running that multi-million dollar campaign for 6 months and then say, oh, it didn't work because of this. You have to hit that starting on day 0, not on day 1. So I think those two things, in my mind, are different from a traditional product market fit that we do for a non-AI ML, at least the software solutions
and it
and
ties to
deployments.
that's a great point about the explainability. If you can't explain why you got a negative result, you also can't explain why you got the positive result, right? Like, so you go and you build a thing and there's no problems
Exactly.
whatsoever,
Yeah.
right? And then either your customers or your investors or your C-level executives, they ask you, well, why does this work? You're like, I don't know. Will it work tomorrow when we get some different data? I don't know. Nobody feels very comfortable if those are the answers, right? So it really is. You have to bake the explainability in, and it comes back down to as you're describing, Miku, as you're describing that chain of causality. I thought about my first DARPA project that we did for when they were using big data, and this was like 10 years ago. They're trying to use big data to do prediction about terrorist networks and all these kinds of things. They're trying to actually use machine learning tools in operational scenarios, right? And what they tried to, we were a bunch of open source nerds and coders and academics and researchers, and they had people wearing all sorts of decorated brass and everything come in, try to explain to us, listen, we're not just looking for the answer. It's not good enough to put a little red box on a truck going down the road and saying that's got some terrorist with a bomb in it, right? No one's going to just push a button just because the software put a red box on it. You've got to explain why you believe this is true. You've got to be able to peel apart the onion and say, what if this data point changed? What if it turns out that report was wrong? And these are things this is literally questions of life and death, and we have a responsibility in that case, right, to give the decision makers, which is ultimately the human in that case, give them everything they need to feel good about the decision, or have some high confidence in the decision they're making. And I think that's the thing about overall, maybe coming out of the conversation thus far, it's that no matter how good the computer systems get, and they're really amazing, I mean, they do amazing things, but no matter how good they get, it's the human-computer interface. When we want the computers to help us make decisions, we have to understand that with great responsibility comes great power. If we rely on the computer to make the decision, then we're ceding all responsibility, or we have to take responsibility for everything there. The bad code, the bad data, the bad models, the bad everything. We are taking responsibility and saying, yep, we're going to let the computer do it all. So usually people are not comfortable with that, and you have to have a level of the humans have to figure out, how do I feel good about this computer system that I will take responsibility for what it decided? And that's where the demand for explainability comes in.
Yeah. Like, think about it, Jordan, right? Like, if first time we put our model, we got 80%, 85% precision and recall, and we were like celebrating. We felt we have made it already, done. And then when we went to our business partners, they're like, what do we do about the 20% where you're going wrong? Like, how do I explain that, and we are fighting that there's no way, right, we can get to
Right.
100% accuracies. I mean, I should not say no way because somebody will blast me, but it's very hard to be at 100% accuracy from any kind of an AI/ML system, no matter what optimizations or levers you have put into it. So that comes back to educating your stakeholders that it's not about what you got right. It's about how do you explain when you got something wrong, and establishing those guardrails very early on. Because for certain businesses, for certain use cases, right, like it might not be acceptable for you to get 10% off, and then maybe the AI/ML can only work in an augmented way because you need to have that human interface, to Peter's point, to override when things go wrong or when it's lower accuracy than what you expected. Certain scenarios it just won't be acceptable. Certain scenarios, like, fine, if I can have the liberty, you miscounted an almond, it might be okay, right? But for some other things, it's just not acceptable.
And so just to come back to you on that with sort of a follow up in terms of if you're a decision maker, or you're someone in a business today that is trying to understand or look at a problem, and they've been pitched that there's definitely an ML solution here, and the teams have gone away and done all the research, and it's like, yep, this is definitely something that can be solved with AI or ML. Like, how would you advise them to look at that in a way, given all the challenges that you've raised, and there's a number of things that you've called out that make it understandable why it can be a very daunting space to get into? But for someone looking to take a decision like that, what advice would you give them on actually how to look at it and see if AI actually makes sense, or if there's something else that should be tried before jumping straight in with a full blown AI or ML based approach?
Yeah. No, this one I've been so
Please,
badly
yeah.
burnt that, Peter, I'm gonna answer Jordan's question, because this is like, where I have the maximum scars, which is not from a business perspective, not establishing the acceptance criteria for an AI/ML system early on. That's the biggest gap today. You say, okay, the system is going to do XYZ. You get excited. Wow, you're getting into AI/ML. You start showing some results, start showing some precision and recall numbers. You optimize, get more data. All of that fun stuff happens. And then the business throws this very important question in a very subtle way, that these accuracies are not going to work for us, right? Or how do I explain that 5% variability? Or, for what we are trying to do, we at least need 90% accuracies, or we are comfortable with 60% of accuracies because at the end of the day, it's still solving X problem for me, right? Like, rather than, it's increasing my sample size, it's reducing my labor cost, it's giving me automation to an extent that I can still accept the system. If you do not establish the acceptance criteria at scale, that what is needed for this system to be running in production at scale, then I think it's a losing proposition for both parties, right? For the businesses as well as the people involved in putting that system together. So that's first. And second one is, like we touched upon it, for businesses to understand that the fun begins when you start thinking scale, right? The change management, the cost, the learning that all the leaders have to go through, all of that has to be planned if they want to see it in production. Again, something which very rarely is top of mind for leaders in the early days of thinking about an AI/ML solution. And then lastly, but the first barrier is that to what extent businesses can help in providing the data set, because however much you build with a generic data set, however much you talk about a standardized industry, honestly, every business still does things their own way, right? In terms of decision makings, because it's their ROI, their revenue at stake. So you do need that, even if you got it to a certain point with generic data sets and training and whatever industry specifications, you still need to close that gap, whatever it is. Maybe it's 10% for some industry, 30% for some industry. how will you get access to that data so that you can optimize the model to the language which that specific business speaks, right? And then that leads to all the fun of data access, data sharing, anonymizing the data. So that's a big bucket of what needs to be established early on uh, from the modeling perspective. Then the acceptance criteria, that's from the business perspective, and the change management, which is again from the business perspective. I think even if you start having those discussions early on, the chances of these systems to succeed as production deployment, which today I don't think it's a double digit number, I might be off, but not by so much. It will get us to a uh, good percentage where we can cross the double digit in terms of how many AI systems today are actually in production deployment at scale, right? And I'd pose
Yeah.
that question to you, Peter.
Well, it depends. Yeah,
Is that double digit? Let me just understand.
It depends where you draw the line at what you call AI, right? There's like every automated trading system in the world, it trades faster than the human could, right?
Exactly.
And it absolutely certain of them have enough complexity that I wouldn't call them AI, but they're certainly doing a lot of stuff that has a level of intelligence to it, I suppose, because they're modifying their environment. And without getting too philosophical in the field about what is intelligent versus what's merely reactive, I think in production scenarios, the vast majority of it is really machine learning. It's really big ML problems. And in terms of actual like AI things, it's not very many in my estimation. And the difference, again, going back to the very original question, right? I think the difference has to be whether the environment that the system is operating in, how chaotic is it? How dynamic is it? If the system is able to change that environment and other live agents and actors are in that environment, responding to the change and changing the environment, and the system in an unsupervised fashion without human intervention is then adapting to that change, the more that it does that, the more I would say it's a kind of intelligence, more so than just simply a reactive, a very sophisticated but still a reactive system, like merely reactive, right? But to Jordan's question around how does someone create these systems, get into AI/ML, or try to adopt it and have any hope of success as they're bringing it into their business? The thing I would say is that a lot of the stuff that you have to do in order to be successful with a big scale machine learning system, those things can be valuable in their own right. It could be a data cleansing, or it could be a data, getting a better sense of what's out there, getting a better sense of what you should be looking at. There's a lot of these little sub problems that feed into being successful with an actual ML problem. So if you have the luxury of a little bit of time and resources, then having the team do some of that initial groundwork will get you a lot of confidence, or at least a better place. It's like climbing up to base camp and then looking at the summit from base camp and then being like, okay, can we actually summit this thing? Versus being like, 10 miles away and just saying, we're going to do it all in one pitch, right? So I would suggest that people, if they're really new to this space, don't be so ambitious. Just use some machine learning techniques to tackle what might seem like more banal problems in decisioning or in sorting or categorization, some real supervised learning kinds of problems that would still add value to the business. At the end of the day, information is a difference that makes a difference. So you don't need a very complex system. I mean, to Miko's point, you could do it with Excel, right? You can do some of these kinds of things with Excel, but the idea is to look at a broad set of data and to take some of these machine learning techniques and use that to approach thinking about the world. Versus traditionally, there's more of a top-down in businesses. There's a top-down modeling. There's a bunch of MBAs with a bunch of spreadsheets, and they have a model they need to conform to. And that's not the ML way, right? So a lot of it is organizational change. You also, if you do that, you also do a little bit of a pressure test to see how much willingness is there in the organization to accept the kinds of organization changes that will be necessary for us to actually scale up an ML-based approach. So that's my answer to that.
And so, I think we've highlighted a lot of the things to think about, and the ways you can get caught out by starting on an AI and ML journey when you're not necessarily prepared and thinking you're going to climb Everest from 10 miles, even further, 20 miles from behind base camp. But to close, I'd love for you all to I won't hold you to this, But if you guys had to predict what the future of AI and ML looks like when it's applied to sort of the marketing domain, like what exciting things or what things do you think are going to potentially happen in this space over the next 5-10 years? And do you think there's going to be expansive changes going to change the way we experience marketing and interface with that medium, or it's going to just be gradual improvements and optimizations that are going to go more unnoticed, do we think? And Miku, I'd love to start with you.
Yeah, I think honestly, with all the things that at Meta we are doing with Metaverse, again, AI is going to be one of the common fabric or threads which is going to run through it. Back to the point of how do we really deliver that 10x, not just in terms of monetization, but also in terms of user experience, right? And if I look at it even more simply, there is still a lot to be done with in the space of videos and reels and images, all these different kind of assets which are kind of the repositories, so to speak, for any marketing campaign, right? So I think we are going to see a lot of new ways of user experiences enabled or empowered by AI when it comes to these kind of use cases related to videos or reels or metaverse in general. I also feel that it's about time where in non-software industry verticals you'll start seeing AI a lot more, like wherever you have a large scale Internet of Things deployment, especially with tiny ML, the ability to reduce the footprint of the models and whatnot, you'll start seeing a lot of this making its way into IoT enabled automation across different industry verticals. So those are the two things I'm pretty bullish about. From marketing perspective, it's like to what extent we can completely change the user experience, the recommendations, become smarter and learn about the campaigns which are successful or not. That is up for change. And in the non-software industry vertical, I think wherever you have medium to large scale IoT deployments to make decisions related to automation and control plane and things like that, there you're going to start seeing big change, especially with tiny ML becoming more and more of a reality. And that processing power, to Peter's point, coming back to into much smaller form factors, which can be deployed into a plethora of different kinds of devices.
Well, so I have lots of thoughts on this.
Peter, what do you think?
I do think that automated systems and cybernetic systems are going to radically transform life for everyone, not just in the developed nations where we have so much wealth and we're just busy being consumers buying all sorts of stuff, right? There's lots of ways that this changes everything for everyone. And I think a lot of it for better, whether it's personalized medicine, whether it's faster relief for disaster struck parts of the world, whether it's remediation of climate change, all these kinds of things are dramatically improved with the techniques that are being developed in AI ML. But specifically relative to marketing, I actually have a deeply subversive hope that the field of marketing as a concept is utterly transformed with AI technologies, because if you think about it, marketing at scale really emerged with the emergence of broadcast technologies, single message, multiple recipient kind of things, and it creates brands, and it creates the other side of the recipient is there's a focus on brands and things like that. And I think what we're seeing across the scale of marketplaces and influencer marketing, all these kinds of things, you're seeing that what people really hunger for isn't to be, no one grows up in the morning saying, I want to be the recipient of a scaled message from a marketer, right? People wake up in the morning wanting to be human, wanting to live meaningful lives, wanting to connect to others that have meaningful things to share with them, whether it's to support or to challenge, whatever it is. We want interesting things in our lives. And so I think that these technologies hopefully can do a better job of connecting people. And then the concept of marketing in the 20th century sense, in the Bernays sense of the term, actually evaporates and becomes something else altogether. And if you're actually a marketer, whether you're a craft marketer on Etsy, whether you're a small local bakery here, like in Austin, you then as a maker are trying to connect to your audience in a much more authentic way. And that authentic connection is, we could call it marketing perhaps, but it does the thing that marketers try to do now, with the kind of broadcast era paradigms, So that's my hope, is that we use these technologies to get better at connecting people, not just like sniping their interests based on what we've gleaned about them and all these things, but actually forming legitimate human connections between people. That's my hope.
Awesome, and that is pretty much all we have time for. So thank you for ending it on a high, Peter. And so I'd like to thank our guests, Peter and Miku, for joining us and sharing, both your valuable insights and really your experience to date on all the things that you've done and the exposure you've had within AI and ML, or any links to anything. Any links to any of the resources that we've mentioned will be in today's show notes. And so thank you for listening to the Business, Innovation, and Technology podcast. If you've enjoyed today's episode, be sure to subscribe and leave us a 5-star review.
Thank you so much. Thanks, Jordan, for being an awesome host. Thank you.
Thank you, Miku. Take care.
We hope you enjoyed this episode on AI and machine learning. We'd like to thank today's guests, Miku Jha and Peter Wang, for their time and valuable insight. You can find links to any resources mentioned in today's show notes. Thank you for listening to the Business, Innovation, and Technology podcast. If you enjoyed our discussion today, please be sure to subscribe and leave us a 5-star review.